Hello. We defined the basic terms about interval estimator, like marginal error and confidence level. And here, let's think about their relationship, and we will think about what is a good interval estimator. First, think about back to the pregnancy due date example. Think about two different estimators, interval estimators. The first estimator, say Doctor 1, there are two doctors. They are estimating the due date on their own method. So the first doctor uh, answers like this. The baby will be born sometime between February 5th to February 25th, right? And the second doctor says the baby will be born sometime between January and March. January 1st through March 31st. So among these two, which is more informative? Which is more informative? So it's just one more question. Just guess and simple. It is easy to answer. I think estimator 1 is more informative. I don't like estimator 2 in the sense that anyone can say that. It doesn't need to be a doctor to guess the baby will be born between January and March. So I knew that it's so obvious. So it's obvious it's not an information. It's not new information at all. So it's not informative. So in that sense, estimator 1, if you can choose between those two, I would prefer this doctor, right? Telling us better advice. But now then think about this way. Which has the higher confidence level? So remember, the confidence level is the probability that your interval estimator is correct. Your interval estimator is correct is the probability is the confidence level. Now, if you compare the first estimator and the second estimator, two intervals, which has the higher confidence level or higher probability of correct estimation? It is also pretty simple. The answer is 2, estimator 2. Because, so for example, if the baby is born on February 4th, for example, then estimator 1 is wrong, but estimator 2 is correct. So, say if the baby is born in January, 2 is correct, but 1 is wrong, for example. So the problem here is, you see the problem. Obviously, the first estimator is more informative. It's a better advice, right? But theoretically, estimator 2 has a higher probability of correct estimation. So estimator 2 is more likely to be correct because it's wide, and it's always the same. This is so true. Like, for example, suppose I don't know who you are. I say you are watching this, and I can guess how tall you are without even looking at you. Like, for example, I can say your height will be between 1 foot, between 1 foot and 10 feet. I will be always correct, right? Right? It cannot be wrong. So simply, it cannot be wrong, so it's not informative. So anyone can say that. No information is needed to say that kind of answer. It's a trade-off. So you want to make your estimator more informative. So your estimator to contain some information that's scarce or that's new, but when you do that, there is a risk, because to make it more informative, you have to make it compact, but then you are losing some probability. So it is a trade-off. So think about this. Estimate 1 has the margin of error of 10 days, but it may be wrong. So 10 days, margin of error 10 days was not enough. Actually, my son was born earlier. But estimator 2 cannot be wrong. cannot be wrong. Nearly 100% it will be correct, but it's not informative. So then our conclusion is we have to be somewhere in between them. We have to choose our stance where we are going to stand between those two. In one extreme, I can say just one day point estimator is one extreme, and the other extreme is a very, very large estimate interval. If you make the interval super large, from minus infinity to plus infinity, it cannot be wrong. But that's not what we want. Either is not what we want. Therefore, we have to choose somewhere in between them, and that's what that determines the confidence interval. How to determine the confidence interval. So, to summarize, there are two desirable properties for a confidence interval. So what we want first is we want to make the margin of error smaller. So the margin of error is literally it's the size of error in your point estimator. The size of estimation error is reflected on the margin of error. So the smaller the margin of error, your estimator will be more informative. On the other hand, you want to make the confidence level higher, right? More likely to be correct, right? So these two are important criteria to find a good interval estimator. But as I said, they are trade-off. You cannot achieve both at the same time. So like say, think about it. Unbiasedness and efficiency did not have any trade-off relationship. So you can achieve the unbiasedness and efficiency at the same time. The example was the sample average. I said the sample average is the best estimator because it achieves both criteria at the same time. But in this case, there are two criteria, but they cannot be achieved at the same time. So there is no single best estimator in interval estimation. Then how can we find the balance? How to choose the trade-off? The answer is the convention is usually so you have to choose. If you choose confidence level, then margin of error will follow. Vice versa. If you choose margin of error, then confidence level will follow. So you have to choose one of them, and usually we fix the confidence level first. So for example, if you want to make your estimator 99% correct, okay, then that's good. Then the confidence level is 99%. This is fixed. You are not going to change the confidence level, but given this confidence level, what you want to do here is you would like to find the smallest margin of error that achieves the confidence level of 99%. So that's what you are going to do to calculate, to obtain an actual interval estimator on a confidence interval. So think about this. So the usual choice of confidence level. So usually, I said, you to choose between those trade-offs, you have to choose the confidence level. The typical levels are 90%, 95%, or 99%. They are typical textbook levels, and in practice, you may choose different ones. But in textbooks, those three are most common examples. And that means, so for example, if you choose 95%, that means you will make your interval estimator 95% correct. Which is equivalent to you will allow 5% error. So you cannot make it 100% correct. That is not, so 100% confidence level is equivalent to like a super wide interval. Meaningless interval will be 100% correct. So you have to allow some error probability, and typically 5% 1% or 10% is used. It's up to you, up to the practitioner, up to the statistician, right? So then given the chosen confidence level, you can calculate the marginal error corresponding to that level, and then using the marginal error, you can calculate the confidence interval. That is called the 95% confidence interval. So we usually use the confidence level to define the confidence interval. Then let me ask you this question. So you can think about three different confidence levels, and they will be different intervals. Then among them, which one would be the largest interval? Think about that. Which one is the largest one? The answer is C. To have a higher confidence level, as I said, so in the earlier example, in the extreme case, if you want to make your interval 100% correct, the only possible way is to make it infinity, like from negative infinity to positive infinity. So the wider your interval is, the more likely correct. Therefore, 99% confidence interval implies wider interval than 95% or 90%. So the higher the interval, the higher the level is, confidence level is, the larger the interval would be. So I want you to understand the trade-off. Or you can think it this way. You want to make the confidence level higher, but you want to make the interval narrower. But you cannot achieve them at the same time. They are trade-off. So higher confidence interval means the widest interval, the largest marginal error. So the answer is C. And then we are going to, I will now, like in the next video, what I'm going to do is we are going to derive a 95% confidence interval for the population mean. So the confidence interval, the construction of confidence interval depends on which parameter you are interested in, but like you can apply the framework to any kind of parameter, but we will specifically consider the population mean, which is general enough and most useful and still difficult enough. So it would be nice if we could study a more general class of confidence intervals, but that's not, that's more advanced level. So we will restrict our focus on the population mean estimation. So our parameter is, from now on, is always the population mean. Then and we know that the interval takes this form. There is a point estimator, theta hat. So theta is the parameter. Theta is now the population mean, which is, so in estimation, we use theta for the parameter, but earlier the population mean was denoted as mu. So it's kind of confusing, but let me, So theta hat is a point estimator, and you subtract and add margin of error. And then, not explicitly given here, but you need to set the confidence level for this interval. So there are three things you have to choose. You have to obtain, you have to calculate confidence level and margin of error and the point estimator. But among them, first, confidence level is what you choose. It is something to be calculated. It is just your choice. And we already set it at 95%. If you would like to increase that, that's your choice. But let me just consider 95%. So one of the three is gone. And the next one is, let's think about point estimator. Point estimator is a totally different issue. And so because you have to think about unbiasedness and efficiency. And like the reason why I fixed the parameter to be the population mean is because its point estimator is known. The best point estimator is known to be the sample average. The sample average x bar is the best point estimator, so you don't need to worry about this. So the point estimator is also naturally chosen, and then the only thing you have to calculate is the marginal error m. Then you get a confidence interval in this framework. So I'm going to show you how to calculate the marginal error in the next video. So see you there.